Tomorrow we have a quiz on Newton's first law of motion, or inertia. So we're going to go through some of the things we have in our packet as a review. What we did first in this unit was we read sections 4.1 to 4.5 in the textbook, and we answered questions based on what we read. So the first question talked about what natural motions are. And natural motions are basically up and down motions that objects go through trying to seek their natural resting place. The other type of motion that's mentioned in the section are violent motions. And violent motions are motions which are imposed on an object, and they are the result of some kind of force acting on that object. Number 3 says a force is any push or pull. Number 4 says friction is, so we wanted to define friction. Friction is the force that acts between materials that touch as they move past each other. Number 5 talked about Galileo, and he argued that only when friction is present is a force needed to keep an object moving. So if we talk about the opposite of that, if there is no friction, then an object that's in motion will continue in motion forever. Number 6 was a diagram that was in the book, and it said when a ball rolls downward, it moves with the Earth's gravity and it accelerates. Then we had when a ball rolls upward, it moves against gravity and it decelerates. And the last part said, if a ball rolls on a level plane, it does not move with or against gravity. And then the last question here on the screen says Newton's first law is also called the law of inertia. Number 8 says state Newton's first law. So we know that every object continues in a state of rest or in a state of motion unless acted upon by a force. So in other words, that means that an object at rest will stay at rest, and an object in motion will stay in motion unless a force acts upon it. So number 9 says, simply put, things tend to keep on doing what they're already doing. Number 10, the amount of inertia an object has depends on its mass. The more mass an object has, the greater its inertia, and the more force it takes to change its state of motion. So think about the activities that we did in lab on Tuesday, and specifically think about the one where we had the overhead sheet and we put the 3 masses on that sheet, and then we pulled that sheet out from underneath the masses. We talked about the fact that the largest mass was least affected because it had the most inertia. And the smallest mass was the most affected because it had the least inertia. So then 11 says, mass is a measure of the inertia of an object. The more mass you have, the more inertia the object has. The less mass you have, the less inertia the object has. Number 12 asks to compare volume and mass. So volume is the amount of space that an object occupies, or it answers the question, how big is something? And the mass measures the amount of matter or stuff or material in an object. And a way that we can remember that is that mass and matter both start with an M. 13 says mass is a measure of, and when we fill that in, mass is a measure of the amount of material in an object. We measure it in kilograms. 14 says weight is a measure of. Weight is a measure of the force of gravity on an object. So weight depends on where the object is because it's dependent on the gravity acting on the object. 15 says compare the mass and weight of a stone on the earth and on the moon. Mass is the measure of the amount of matter that's in an object. It does not matter where a particular object is, so the mass of our stone will be the same on the earth as on the moon. But weight depends on gravity, so the weight will be different on the earth than on the moon. The earth has a greater gravitational force, so it would have a greater weight on the earth than on the moon. Number 16 says to define mass and weight. So mass is the quantity of matter in an object, and weight is the force of gravity acting on that object. And we can symbolize weight with an F subscript G, which stands for the force due to gravity. 17. Mass and weight are proportional to each other, but they are not equal to each other. 18. In most parts of the world, the measure of matter is commonly expressed in the units of mass, and the SI unit for mass is kilograms. And if we know that 1 kilogram equals 2.2 pounds, we could do a conversion from kilograms to pounds or from pounds to kilograms. For number 20, it says the SI unit for force is, and that would be newtons. And we know that 1 kilogram equals 9.8 newtons. So again, we can do a conversion from kilograms to newtons or from newtons to kilograms. And finally, in question 21, it says weight equals, and to calculate that we would take the mass of the object in kilograms and we would multiply it by the acceleration due to gravity, which in this case would be 9.8 newtons. We also needed to read section 4.6 in the textbook and answer some questions based on that reading. So for number 1, it says, in the absence of force, objects at rest stay at rest, and objects in motion continue in motion. Number 2 says the combination of all forces acting on an object is called the net force. Number 3, what is a normal force? The normal force is considered to be the supporting force, and it's basically the opposite of your gravitational force if your object is not moving up or down in the vertical direction. Number 4, when an object is at rest with a net force of 0, we say that the object is in a state of equilibrium. And in that case, since it's in a state of equilibrium with a net force of 0, if the object's at rest, it will stay at rest. And then for number 5, it asked us to describe the diagram that was in the book in figure 4.12. Okay, I just made a free body diagram of that. So we had the force due to gravity acting in the downward direction, and then we had 2 forces acting in the upward direction, and we know that the sum of the rope tensions must be equal to the weight acting down. All right, so when we look at this exercise, we have a girl with a weight of 300 newtons, and we've got different ways that she is set up, and we want to determine what the net force is. So we've got our first diagram where we've got a girl who's got 300 newtons of weight acting down, so her force due to gravity is 300 newtons. So we're going to have 300 newtons acting in the opposite direction, which will give us a net force of 0. For number 2, we've got the same girl with the same force due to gravity, 300 newtons. So the opposite force must be equal, which is 300 newtons. And each of those scales is going to feel that 300 Newton force. And then in the last picture on this page, we've got that same 300 Newton girl, but this time the force is going to be equally separated between the two ropes. So we've got the force due to gravity is 300 Newtons going down, and we've got the force on each rope being 150 Newtons. So 150 plus 150 will give us 300, and our net force is 0. Okay, for our next pictures, we've still got that same 300 Newton girl. But in number 4, that force is going to be spread out between 3 ropes. So we'll have a 100 Newton force plus a 100 Newton force plus a 100 Newton force. We'll cancel out the 300 Newton force due to gravity, and our net force will equal 0. For number 5, it doesn't matter that we've got a pulley system there. If we've got 300 Newton force acting in the downward direction from the force due to gravity or her weight, we're going to have a 300 Newton force acting in the upward direction. And then for the last one, we've got the 300 Newton girl. She's hanging from the rope, but she's also hanging on to the edge of a cliff or whatever that might be. Okay, let's just say that that force is 100 Newtons. That would mean the scale would feel a 200 Newton force, because 100 plus 200 would equal 300 Newtons up, canceling out the 300 Newtons going down because of the force due to gravity. So the net force is 0, and the girl wouldn't move. The last set of free body diagrams we have has a man with a weight of 800 Newtons, and it also says this time that the plank has a measurable weight of 200 Newtons. That means together, the force due to gravity is 1,000 Newtons in the downward direction. So that means if it's not moving, the force in the upward direction also has to equal 1,000 Newtons. So if he's standing right in the middle of that plank and there's 500 Newtons on the first scale, there must be 500 Newtons on the second scale, since 500 plus 500 equals 100 going up, which would cancel out, or 1,000, which would cancel out the 1,000 going down. For number 8, now he's not standing in the middle of the plank, he's standing more towards the right, so the forces are going to be shifted. We're only going to have 170 Newtons of force on the left-hand scale, so we must have 830 Newtons of force on the right-hand scale, since 170 Newtons plus 830 Newtons equals 1,000 Newtons up, which would cancel out that 1,000 Newtons down, and our net force would be 0. On the last picture, now he's hanging off the edge so that there's no force acting on the spring on the left. It all must be acting on the spring on the right. So if his weight is 1,000 Newtons in the downward direction, the force on that scale must be 1,000 Newtons in the upward direction. The last 2 sheets I'm going to do on a second video.